Awesome. Thank you. Welcome back from the break. I had some great discussions with people on GatherTown. And I'm really excited to see that from our polls of exactly 3 people, 5 people have said that they can still install the Docker, which is very exciting. So I'm going to turn the floor over to Sejal, who's going to tell us about R and R Markdown.
Awesome. Okay, so let me just share my screen. Can people see this?
I see it.
Yeah, awesome. Okay.
I don't see it in presenter mode though. I see. Oh, now I do.
Yeah, better. Okay. Okay. So, so the next section for like about 10 minutes or so, we'll be going through R and R Markdown. It's going to be a very brief introduction to it because we'll be using these in the workshops. So what is R? So R is a language and environment for statistical computing and graphics for data visualization. It's similar to S programming language, which is used really long time ago, and an environment. So it plays off that. So in the next 2 slides, I will be briefly going over our programming and the interface of Rstudio that we'll be using throughout the workshops. Our program is powerful and it can be used to handle a wide range of data sets from small to large. With different statistical analysis can be done. And in terms of this, the advantage of our scripting is there's different packages that can be used. And these packages can help us in terms of data manipulation and also data analysis. So before Rstudio even came out, it was an old way of doing this, which was our graphical user interface, which is years ago. And it was mostly command line. And you only so there's the figure on the left. You just had 2 panels. So the first panel was basically where you write your code and you also get the output of your code. And if the code was in some sort of form of applying a graph, you get a pop-up window that had this graph. But now we've moved into a more new way of doing this, and it's called Rstudio. So I'm going to go through a demo just briefly in terms of interactive demo, but what I want to show you is the different panels that is there. So the first panel would be the Rscript or code editor. So in this sense, what happens is you can write your code and then you can run your code with this run button. And the output of your code comes down into this terminal, which is your R console. And if your code does have, if you're scripting in terms of getting a visualization, such as a plot, it will pop up in this section here, which is you can see your files and graphical output. So this will make a little bit more sense as I go through the interactive demo just in the next slide. And then the last one is our environment. So in your code, if you're storing data in your variables, when you run that, you can actually see your list of variables or your data frames in this our environment panel. So I'm just going to end the show right now and move to the Rstudio. If you guys were able to get Docker in the Rstudio web part open, here is the interface. So just imagine this is some code. We'll go through the code later, the next few slides, but just imagine that this is some code. And I want to run all the code. So I'll just put this run button. And this is what happens. So in this output panel here, we can see some tables summarizing of the data set that's being used. And the part of the code also had a plot. And we can see this plot right here in this panel. Now, this panel has different tabs. So the files here, we can actually see your your directory and the files within that. So you can go back and forth to different folders to pull up different scripts if it's located in different folders. And as we see the plot tab, the output of the tab, the output of your visualization pops up here, and packages. So as I mentioned before, there's a lot of packages that we can use to help us in data manipulation and also analysis. So here's a list of packages that you may have in your library, but you can also update the packages and also install new packages. And the help viewer here is actually just the R manual. So you can actually go to different functions and actually search the packages or functions and get more help of how to use that in your code. Lastly, if you look at here in the environment section, you can see that these are the different variables or data frames, and you can see what each data frame has in terms of number of observations and number of columns. The interesting part is also you can get through a history, which is almost like just a plain text of all the functions or all the scripts, scripts that you ran in terms of the lines of the scripts that you ran. So here's just a brief. This was just a brief introduction of what Rstudio is. Just to go a little bit back, in terms of the file, if you want to get a new file script, you can just go to New File and you can do an R script. In the next few slides, I'll show you what's the difference between our script and our notebook. So I'm just going to go back to our presentation. So this is what we just went through in terms of the demo. So a little bit about R scripting. So let's get back to the general structure of the R code. So there's been a long debate between how to code in R in terms of base R and tidyverse. So depending on when you started learning R scripting, some people would say before pre-tidyverse existed, people would use base R, and which was easier compared to tidyverse, which is a lot of people now, if they want to learn R, they find tidyverse a bit easier to learn because, as you'll see, tidyverse is really great with data manipulation and also visualization. And usually, generally, tidyverse is easier to learn than base R, but they both have their advantages and disadvantages. So here is here's a few examples of base R, which would be in this column here, and tidyverse, which is deployer is a package within tidyverse. And these functions actually help with data manipulation. So you can see the equivalent from base R to deployer. The reason why I'm noting this right now is throughout the workshops, you see a lot of the scripts that we've been using will jump between tidyverse and base R. So just a little bit about tidyverse. One of the main advantages, as I mentioned, was that tidyverse has a logical flow when you want to script and manipulate data sets and visualization. So as you see in this figure, it shows an overall flow in terms of data manipulation and visualization. The point of tidyverse, or even the name in tidyverse, is tidying up your data set. So that's what it helps you do. So in the beginning, if you look at it, we can see in this figure, the beginning point is importing the data. And now the next point is to tidy up the data or format the data in a way that will help you with your analysis. So in terms of formatting the data, we transform the data. And that's where we manipulate the data, such as selecting variables, filtering or reordering it to help you in your model. And then also we can visualize the data. So ggplot is part of the tidyverse universe kind of thing, in which it helps you plot the data that you want. And then the model, so any analysis that you want to do. And it becomes an iterative process depending on what data you want and how you want to format it. So what you find is when you see a lot of people using R script or R notebook. So with the R script, and I'll go a little bit into the demo of what's the difference, is an R script can be used to write your code, and the file extension for that is .r. But when you write your code, as you saw in the interface of Rstudio, you write your code, and then the panel below it shows the output. So you're using two different panels, whereas our notebook is a little bit more user-friendly. In terms of when you do have your output of the code, when you have your code, the output of the code output is just below that code chunk. And I'll show you that in the example. So, and this is more user-friendly in the sense that you can document the code and report. Your report can include the code and the output at the same time. So it's kind of like having a more finished, easy document to read. Also with the notebook, you can actually add other coding languages such as Bash or Python. And with the notebook, it's easy to collaborate with other people. And also you can do a version control system, which is easier to see the different versions. And when we look at our notebook, it's easy to convert into our markdown file, which we'll go through the examples. So just a little bit about R Markdown, and then I'll move on to show you the examples of notebook, the script, notebook, and the Markdown. So R Markdown provides a way of authoring framework for the data sciences. So it's a fully formatted document that can be in PDF or HTML. And this document can contain written plain text, and there's special characters for formatting, but then also includes your R code and the output of your R code. So this is a really great way to kind of show a high quality report that includes the code. So our notebooks can be produced into the following formats, which is the PDF, HTML, or even Word. It allows you to create a report that describes the data set analysis and results, including the code and the output of the code in such as tables and plots. So the main package that is used for this is knitr. And the process of this in this figure is, say we have the R notebook. This function here in knitr is basically what it does. It executes all the code chunks and it creates a new markdown document, which is .md. And this document includes the code and its output. The markdown file is generated by the knitr and is processed through pandoc, which is responsible for creating the finished format to make it look like a report. So it sounds a little bit complicated, but basically what it's doing is this simple function of knitr compiles everything and it presents everything in more of a report format, which I will show you in the demo. So let's go back to the demo, and you should be, so just go a little bit back. If you guys have the Docker and and cloned the GitHub repo, you should be able to see the files. So if you go back here, the two files that we will be working with is the day one script, and which is .r, and then also the notebook, which is .rmd, so it's day one demo. So if you go a little bit back to the script, let's say we are looking at, let's start off with a data set that we're interested in. So we're going to be using one of the data sets that is already built into R. And this would be a data set of data ISOF, and which would be as of. So it would be like a data set for case control studies of esophageal cancer, which is in France. So basically the data set composes of 88 individuals with the alcohol and tobacco status, which is in categories, and it's how many cases or non-cases within each category, divided by, not divided, but based on age groups. So in terms of our script, let's say we load our library. So we're going to be working with tidyverse and ggplot. So if we load that, we can see that when we load it here and run it, we get the output here. So let me just clear this so we can start fresh. We see that. And then if we run the data that we have, we can see that if we get the summary of the data, we can see the different age groups, and we can see that the alcohol consumption is grouped into categories, same as the tobacco. And we can see the mean, median of cases and controls. So if you look at how the data is kind of represented, we can have like just a snapshot of the first 6 rows. And we have the age group, alcohol consumption, tobacco consumption, and the number of cases within each combination. So the cases would be the disease state or the controls. So this is kind of how our script works, where you're writing your code and you get your output in the other panel. However, when we go to our Markdown, it's more user-friendly in a sense that when you run your script, you would get your output right below the code. So for example, let's look at a new, how to open up a new notebook. We go to new file and we see a new our notebook. If we just click on this, it actually shows you the information of what our notebook is. So basically, like I said, when you execute the code within the notebook, these results appear underneath. So they give you a test code chunk. So if you actually run this data, what you'll see is plot cars. So I plot a data set name cars. And what you'll see is, there we go. You see the plot underneath the code. So a notebook is a little bit more easier because at least you're now jumping between the two panels. And you see that once you have the notebook, you can actually make it into a markdown file. And the reason is we're going to be using this because a lot of the workshops that we're going to be doing is going to be following this type of layout where you have the code and you can run it interactively to get the output right underneath the code. So going back to now our notebook example. So I went through just really fast about the R script in the data set, but we'll go more in detail using the notebook, which would be easier to follow. So this is the day one demo notebook. And what we're going to be doing is I'm going to be running the chunks, and I'll just walk through the chunk of code. So with this one would be, we're loading the libraries, which is tidyverse, ggplot, and knitr. These are the libraries we need in terms of our visualization and our analysis. So when we run that, it's just loading the libraries, which we won't really see an output at that point. And then what I mentioned before is in notebooks, we can actually use different coding, different types of codes. So in this example, we're going to be using just a simple command in bash, which is ls. So if we run that, it will list all the files that is in this folder, as we can see in this panel right here. And then we're going to work with that demo data, which was the esophageal cancer data set. And when we do head, we can actually just see the first 6 rows. And then the summary, we'll see the stats of the data. So if I run both right now, we'll see that we can jump between 2 tables. So we have the data frame here, which is just the first 6 rows of the data. And this is the stats of the age group and the mean, median of the end of the cases and the controls. So you can see that you can jump from one table to another. So it's a little bit more interactive than running this in a script. So if we just close this, then the next, so let's say we have a question now. So I'm going to be combining a little bit of what I talked about in the previous slide between R and tidyverse. So next, our question will be like, what age group has the highest number of cases under alcohol consumption? So we can answer this question using base R and tidyverse. And I want to go through these 2 examples to show you how different the coding language, the coding style is in R. So the first one will be base R. So what we need to do is select the variables that we want to work with. So we need age group, alcohol group, and number of cases. So in terms of that, we're storing that into a different data frame. And then we want to reorder the data frame and decreasing to see what's the highest number of cases in the age groups. So when we run this, we're going to get 2 tables. So when we do head of this, we only get the first 6 rows, which is just a data frame. But cable is a function from knitr package, in which it just makes it look a little bit more presentable. So we go, which is this table here. So this is how we do it in base R, which you can see that there's many steps just to get to what we want. Now let's try to do that in tidyverse. So with tidyverse is you're going to work with pipes. So this type of format is called pipes, and it's more logical. So what I mean is, say this is our data set. And we want to select the variables, which is the select function, and these are the variables we want from this data set. But also when we select it, we also just want to arrange it in descending order based on number of cases. So all of it can be done in one line, and it's also more logical of what is being done, and easy to read the code and see what is actually being done in manipulating the table. So in the same format, we can just run this, and we'll have the data frame, and then also a more fancier way to show it in a table. So then the last part is the visualization. So say we're running this, just the plot. We're going to be using ggplot. Sometimes you might see in some of the workshops that they'll use ggplot or base R plot. So you can go back and forth depending on what's easier to visualize your data set. But And personally, I feel ggplot is much easier to use. So what we're going to be plotting is the number of cases in each alcohol consumption group, which is grouped by ages. So it's just going to be a basic bar graph. And what we'll do is just run this, and we can see the code right at the bottom of, we can see the plot right at the bottom of the code. And this is how the graph is. So in terms of the ggplot, you can always play around with ggplot in terms of labeling the different axes the way you want it to be more informative and more presentable in the report form. So that's a little bit about our notebook. Now, the main thing is now, how do we make this into a markdown? So what we can do is, if this knit button right up here, if we want to make it into an HTML document, we can just put knit to HTML, and it'll run some stuff at the bottom here, and you'll get an output right here. And all of this output will actually include the text, will also include the code and the output. You can also get a table of contents, so you can always link back to different sections. Now, the best part about our notebook is that you can actually change what you want to show on the markdown. So say, for an instance, we don't want to show any code for the plot. So what we can do is, in the settings right here, we can actually, okay, so this is already, so we can actually go to show output only. So if we apply that, and we can do the same thing for the manipulation of the data. So if we go to setting and show output only, and apply, and output only, and apply. Now, if we run this again, and then if we see the code with this data, now we don't see the code that we use to answer these questions. All we see is the tables. And same thing with the plot, we just see the plot. So our notebook, it's really nice to, we can actually kind of manipulate and choose different options of what you want to show in their markdown file. Also, what's another good handy thing is, so these number signs or hashtags, they actually give you, they actually define the headings. So when we pull up, the HTML, let's do that one more time. We can see the headings of demo plot. So the more hashtags you put, the smaller the headings get in size. So if you look at Tidyverse, we can see that's 3 hashtags and they're small in size. So there's a whole reference library, not library, but reference document where you can actually manipulate your text. And I'll show you the reference where you can get all these fun stuff in the next few slides. So that's kind of what our studio is composed of in terms of our scripting, and then our notebook, and then Markdown. So majority of the presentation will be focusing on our Markdown. It's just easier to walk through in terms of a tutorial setting. So I'm just going to go back now and just finish off and summarize what we've done. So let me just there. Okay, awesome. So we went through our script demo, and then we went through our Markdown, showing that it's much, I guess, it's more user friendly when you use when we use a notebook in terms of seeing your code and then seeing the output at the bottom. And we went through just how our notebook, a new notebook will look like. And now here are some references that really help a lot. So there's a website, and there's R4 Data Sciences, which helps you in a lot of different functions and different packages and what R is all about if you want to know a little bit more. And also it's a good reference book, or also the website has it too. It's a good reference in terms of if you have any questions of how to do certain things. And another thing is, if you go in your Rstudio, if you go to help and you go to cheat sheets, there is a wide range of cheat sheets on Tidyverse or Markdown. So obviously, like, these functions and these scriptings are really hard to remember how the syntax is formatted. But these cheat sheets help a lot instead of trying to Google how to do certain things. So yeah, so that's the part of our Rstudio, and I guess we'll move on to Jupyter Python.
Oh, RMD and MD. Okay. Actually, we had a good, not stupid question there. I'll post it as a question.
Awesome.
Sejal, do you want to answer the question about the difference between R Markdown and regular Markdown? Or?
Right, yeah. So like R Markdown is just using, I'm assuming, Erin, you can chime in too. It's just with the R language. So basically it's still a Markdown file, but you're using, it's more specific to the R language using knitr in that sense.
Yeah. Yeah, so you'll see like README files in GitHub are written in Markdown. And so R Markdown combines Markdown with chunks of R code. Yeah. So when you see R Markdown, it means that you can run it in knitr to get the parts that aren't written in R visible the way they would be visible on GitHub, like with headings and tables and bullets, and the parts that are written in R will be executed, and actually the results will be printed underneath. So R Markdown is like an extension of Markdown that includes R code. That leads me into actual Python. Oh, I got to share screen to make this work. Okay. Cool. Okay, so for this bit, I'm actually going, so for the Python bit, the next bit is a little bit of a demo, and I'm going to show you how I got here. So there's two ways. We're going to try this two ways. If you want to follow this demo, you can type Docker compose up Jupyter, and then you actually should see a bunch of stuff getting posted to you, including like a web address at the bottom of your console. And after that happens, you can copy and paste it, and you'll have Docker Jupyter. I'm going to show you the second way, and there's instructions about this in the M space. I'm going to show you a different one. Actually, maybe I should show you the Jupyter way too. So if I open up PowerShell, okay. So this is a getup. This is Windows PowerShell, which I hate, but we'll get there. So if I go into code KCNI, school lessons. Okay, now that I'm in the KCNI school lessons repo, if I type Docker compose up Jupyter, I should see things happening, hopefully. Cool. And then at the bottom here, I see these two web addresses. If I take this web address and copy it and put it in my browser and go to it, wait for it, magical, I will see a folder with KCNI. I will see a Jupyter instance that includes all of the code. And today I'm going to be working inside the day one code in this example Python repo. A reminder, going back, if you also look in day one, that example R repo, this includes the scripts that Sejal was just going through for R. But back to day one and example Python repo. The other way to get here for people who, we had like a 2/3 could install Docker and 1/3 couldn't install Docker. The other way to get here, and this is a little more complicated, if you go to the original KCNI School Lessons site, click on day 1, click on example Python repo. Wait for it. You will see a little button here that says Launch Binder. I believe this is the right button. Yes, this is the right button. If you click on this button, it should open a page. Well, it should take a few minutes, but then eventually, oh no, it didn't work. This is the sadness of Binder. It'll take you to this page, and actually it will time out if you don't touch it. That's probably what happened. And hopefully it will say found built image launching because it's going to a server where I just clicked on this button, so the Docker should already be built. And you should once again see the exact same contents as this example 1 repo. So regardless of where we do this, I'm just using these 2 pages to be able to navigate a little bit about the Jupyter environment. So Jupyter, which stands for Julia Python R, is a different coding environment other than RStudio, which is more popular amongst people who code in Python, but offers a lot of the same functionality that we were talking about with R Markdown. So when we look at the Python lessons that we're going to be doing later in the week, we're going to be working usually in Jupyter or Google Colab, which I'll show you a little bit later. So in Jupyter, this main screen that you see is something called the file browser. Oh, and actually, before I do this, I wanted to uncover a Python poll about how much you guys have already seen of this type of material. Okay, so yeah. So to navigate to a new, so all IPython notebooks, so INB stands for IPython notebooks, are a type of notebook that we usually use in the Python land. And we can navigate to it by clicking on it. And if we click on it, it should open in another browser tab. So we're seeing it opening in another browser tab here. And we'll see an interface that looks like this. So with this interface, we have a few things that we can do. The very top, this cell, I said this cell is written in Markdown. So that's this .md language, or the same part as IMD. If we double click on it, we can edit it. And you can say, like Sejal said with Markdown, that double hash signs are headings. We can edit, we can add a new line. So this is essentially a place where we can write any kind of text that we don't want to execute, but we want to make look cool. So this is especially really useful in tutorials. We can use chunks like this to add a lot of information about what the code is going to be in the next section, to link to, we can get really fancy, we can link to pictures, or link to external content with hyperlinks. Actually, maybe I can intro that. Yes, and then we have a hyperlink. Yes, so some people are having problems where Binder appears to be perpetually loading or restarting. That we'll get a bit more into how Binder works and why it can be a pain to wait for it to load. Sometimes you might need to go ahead and reload, because hopefully you'll get onto a server where somebody has the image built and it will load faster. We will see. Okay. The other thing that can exist is you can get a Python code. So by default, if you ask for a new block with this little plus, you should get a block that's actually for Python code. So this block is actually written in Python. It has print hello world. And if we run it, either by clicking this button or clicking, I think it's enter, or no, control enter, shift enter, we can make Python things happen. So we can do little computations. 5 plus 6 equals 11. And I also want to say, so this Python uses the Seaborn package. So this is a more Python code where we're going to be importing the package Seaborn. Seaborn's like one of my favorites. It makes plots that look like they came from R, except they're in Python. And we're going to be importing a data set called iris, which is about flowers that are irises, using a Python function. I'm sorry, we can either run this code by clicking Shift-Enter or by clicking Run above. So this is an example. So when it loads iris, it's actually loading it as a pandas data frame, which is a function in Python that makes data frames like data frames in R. And if we run it in a notebook, it will display nicely. And then we're using just like above. Oh, and notice as we run it, it gives you a little number to say in what order it was run. So we can actually do silly things like run this completely out of order. And now we can see that this was run and then this was run again. This is fun to do as you're practicing your code, but kind of annoying or becomes an issue. So it's a good practice to try to run everything in order or try to build your cells into order by the end of the day. We can also create a plot, a really pretty plot of septal length versus septal length. And or a cool B-swarm plot. Ta-da! Very cool. Now I actually want to show, okay, so I'll go back and I'll tell you what I just told you with a slide. So I just wanted to remind you a couple things about working with Jupyter. Wait for it. Okay. Two important things is that this whole area is the file tree. If you forget where you are in the Jupyter notebook, you can navigate the folders with this little part at the top, and this shows you which folder you're in. Another important thing is that you can see that notebooks can be running or not running. So there's two different notebooks here. And the ones that are in green are actually running, so they're usually open in another tab. And then in the Jupyter interface we saw cells written in Markdown. We saw cells written in Python. We saw the little button to add a new cell, and we saw the button to run a cell. Okay, now I'm going to show you the exact same code, but written in Google Collaboratory. So Google Collaboratory is another space that's put out by Google. To get to it, I'm going to show you. Oh no, I lost the repo. Okay, to get to Google Collaboratory, go to day one code, and there's a little bit of an example. Okay, so Google Collaboratory is a space created by Google. It's essentially, like the name Collaboratory, a space to share notebooks and to work on them together. So if you go to Collab Research, I'm going to open it in a new tab. It will open a page that looks like this. We want to go to GitHub because we want to import a notebook that's already written on GitHub. We want to give it the URL of the example repo that we're using. Oh, I found KCNI School of Lessons, so we found all the things. We don't want that. In this case, it found one repo, example notebook.ipy. And then Google Collaboratory has all of the same functions as Jupyter. It just looks a bit different. So some of the buttons are in different places. So we still have buttons to add new notebooks. We have add code or add code, in this case, Python code or add text. We can still run code. In this case, there's a little, we can move the blocks up and down. We can edit the code by clicking on the little edit tab or double clicking on it, I think. It also adds a really nice markdown preview on the side. And Importantly, to run code, if you hover over it, you'll see a little plus sign. Run it. And then you should see answers showing up below, as so. So we can do this going through all of our other lines. And all of the same code will work. So the nice part about this, and we'll go through it a little bit. So Google Collaboratory can be pretty awesome in terms of the fact that hopefully that link actually worked a lot easier for everybody than the binder link that kept refreshing. And remember to go to GitHub, to put in the name of the repo, and to navigate to the notebook. Get it? And remember, we have all the same controls, but sitting in different places. So it's a little bit confusing. But we still can add new cells. We can still have Markdown cells as well as Python cells. And we still have a little button to run the cell. Oh, and one other thing that exists in Colab but doesn't exist in notebooks, in Jupyter notebooks, is this arrow, and it's important to notice it can hide cells. It can hide or collapse cells, the kind of same way that you can hide or collapse bits of websites. Okay, so Google Colab has some strengths that you might have already noticed. You get a little bit more power and more disk space compared to Binder as a cloud instance. And you can leave it up running for days, so it won't time out on you the way that Binder can. Binder can actually time out on you after 10 minutes if you don't touch the code, which is quite annoying. For working with your own code, you can connect Google Code to your own Google Drive in order to have more space and to be able to read and write files to there. There are some caveats, especially caveats that are important to remember for this course. The first is that each Colab notebook is its own island. So every Google Colab notebook does not know about the other notebooks that exist in the same repo. So it doesn't know about everything else that exists in the GitHub repo when you open it in GitHub. It doesn't know, it doesn't know about any data that might be sitting in the same folder. So any data or other code needs to be linked explicitly. The other thing, which is kind of a plus or a minus, is that every time you start Google Colab, it starts up the notebook in essentially a clean-ish Python 3.7 environment. That clean-ish environment has actually a lot of scientific packages already installed. So Seaborn that we were working with is already installed. A lot of machine learning code is already installed because the Google people like their machine learning code. And a lot of numerical code is installed, but some of the classic packages that we like to use for neuroimaging might not be installed. So you have to just install them directly inside the notebook. Oh, and actually I forgot about bash commands. That's important to show. So to install things inside Colab, you can actually use a trick that anything in either Jupyter or in Colab that starts with a exclamation part is actually in bash. So I can say pip install, actually I forget how to spell. I'm going to say Nylearn. Nylearn is a package that I really like because it works for neuroimaging analysis, and that's how I would actually install. So as you're working with this, if you are working in Google Colab because you couldn't get Binder to start up or you couldn't get the Docker to start up, note that some of the Jupyter containers will have commands like this at the top, and if you don't run them in Google Colab, then everything won't work. Okay. The other thing, which is kind of a downer, is that Google Colab only gives you one version of Python. It has to be Python 3.7. And that means that different software that only works on Python 3.8 or on newer versions of Linux, you won't be able to work with in Google Colab. So I did notice that for one of the packages that I really wanted to show you guys. it was very hard to actually get to install in the Google Colab environment. Okay, so that was a bit fancy, but now we're moving on to the super fancy fun part, which is talking about how to build environments. So allow me to geek out. Hopefully this will be really interesting, a really interesting last bit of the talk. And hopefully even if you don't want to build your own environments today, this will give you the information that you need to be able to really explore other people's code and understand what their dependencies were and understand how to install and how to get things working. So I'm going to start with Binder. Binder is the link that I tried to give you guys, and I'm going to tell you a little bit about what happens with Binder links. So from your laptop, I give you a link. That link has an address or has a certain format. It starts with my binder, v2 for some reason, GH for GitHub, and then it has user, repository, and branch. So usually head or master branch, and then it could have other stuff. It reads this information, GitHub, user, repository, branch, to talk to GitHub. And what it does when it gets to GitHub is it copies your GitHub repo into a cloud, into a little Docker instance that's on the cloud. So it starts up a Docker instance. That Docker instance already has a version of Jupyter and a version of Rstudio inside of it. And then it reads from the GitHub repo some files about how to configure things. I do not know. Okay. Ow! Okay. Wait, I'm going to move that. So, it'll come back. So we had a question about cannot read from file system. So in this case, this might be, I'm going to escape. So we just had a question about Docker installs. So give me a second. I'm going to go back to here. Yes. So if you get an error, with Docker style that ends in read-only file system unknown, it might be because you need to share the drive with Docker. So to do that, you need to open up Docker Desktop, usually. Go to Settings, Resources, File Sharing, or click on the little arrow for Settings. Go to Resources, File Sharing, and make sure that your drive is shared with Docker. Once you do that, you might be able to actually read from the Docker image. Cool. So I'm going to go back to Binder. Okay, so to remind you, Binder is a website in the cloud, and it takes your GitHub information and some other stuff in the file address. It reads that as a command to copy from GitHub into the Docker, to build a Docker that contains Jupyter and R, to read from files in the repo to configure the installation of other things into that Docker. And it takes that Docker and it makes a copy in the cloud for the next user, which hopefully means that the next person who clicks on the link won't have to watch a million things start the way that you did. And then it takes that repo, so it takes either Jupyter or Rstudio, and it feeds it back to the user. So you see either a Jupyter or an Rstudio interface. So there's two things. So the configuration files that you need to make this work. In Python, it's very simple. All you really need is a requirements.txt file. If you've worked with Python packages before, you might have seen this file. It's very popular in a lot of different other Python repos. And it usually just lists all the packages, all the Python packages that need to be installed, and usually something about their versions. The other thing you can add is this runtime.txt, and that is a small file that actually just contains exactly the version of Python that you want. And you can see an example of this in these two files inside the example Python repo of the day one code. For R with Rstudio, this actually takes much longer to run. Binder likes Python better, I will admit. You have a runtime.txt, which tells Binder exactly which version of R you're going to ask it to use. And then there's install.r, which is actually just an R script that installs any R packages that you want in the environment. And there's an example of this in example.r. So I'll show these two environments. Actually, no, first I will show you. Yes, I'll show these two environments. So inside the Python repo, I have a requirements.txt file. And inside that, I told it to install Seaborn and Pandas. And I have a runtime.txt file, which just literally has the word Python 3.8 because I told it I wanted a Python version 3.8. Oops. Okay. And if I go back, to the lessons, and return to the R repo, I see install.r script, and this says 2 lines, install packages tidy first and install packages R markdown to make this work. Oops. Are we losing my audio? Oh dear. Okay, I'm going to close things down. Am I back?
Yeah, you sound good.
Okay. And going back to this repo, I also see a runtime.txt. And this one says that I want R version 4 or higher, and I want a snapshot that was taken about a month ago in June. Okay. Awesome. Okay, so to remind you, in Binder, did this slide work before? We'll ask. Okay. Okay. When I do in Binder, you add those extra bits, those extra 2 little files. And then the other critical bit is the actual address that you give them. So Binder uses the address almost like a command to figure out what it needs to do. So the classic thing is my binder, GitHub for GH, GitHub user, GitHub repo, and branch. So this is an example, Krembil Neuroinformatics, which is the GitHub group. Example, Python repo, and head, which just means the newest version. And that's what I use to open the Python instance. I could have given it, you can give it some extra fun stuff, like you can add question mark file path equals file path in this example. So I added question mark file path equals example notebook.ipnt, and that sends the user directly to one Python notebook instead of to the file browser when they started out. If you want people to open up R, then that's when you need to type So if you wanted to start in R, you add $, or not $, question mark, URL path equals Rstudio to the end, and that tells it to use Rstudio instead of Jupyter. So that's what I did in this case with the example R repo. It's Krembil Neuroinformatics example R repo head $, URL path equals Rstudio. These are crazy links, so the key is that we try to put those links in as many places as we can, and sometimes we add pictures to them, like a binder badge, so that people can link to them. Also, if you go to mybinder.org, the first thing it will show you is actually a website that helps you build these types of links, just with little drop-down menus and things. Okay, so that was binder instances, which are really nice, but as you notice, there's some caveats that they take a long time to load up. And I'm going to talk about Docker. Okay, or how to build your own Docker files. So writing a Docker file, if we look at them, they usually have a couple simple things. So the first thing about writing a Docker file is writing for Dockers is that the script you write for a Docker file is always called Docker file. Literally, like it has to be the word Docker file. I don't think you can change it to anything else. And usually you put that word called Docker file, you put it in a folder by itself, because everything else that goes in the same folder as a Docker file will get imported into the Docker. So usually you create an empty folder or a new GitHub repo and you put a file named Docker file in there. The first line you end up writing in a Docker file is from. So from means that from references and then afterwards another Docker file. This seems a little silly, but this is something I'm going to talk about, things that we can go from. In our Rstudio Docker, we say from Rocker, which is an amazing group who make Rstudio Dockers for us. So we have everything we need other than that. So usually you take from and you point to somebody else's Docker on Docker Hub. And then you add something, and then you add commands that start with run. And everything after run looks like a bash installation command. So if you've installed anything in bash, it's literally the exact same. You copy and paste the code. You can also, so every time you type from or run or any of the official Docker commands, what you're creating is a new layer. And every time you create a layer, it becomes kind of a point that you can share across multiple Dockers. So sometimes you might want to package more than one thing into a layer because there are two different install commands that relate to the same thing. And to do that, you put double ampersands or double ands in between two lines of installation. If you want to learn more about writing these, the easiest is to just look up a lot of examples. So Docker Hub is the place with all of the Dockers, but you can also look inside KCNI School Lessons EMVs to see the exact Dockers that were used in this course. The last thing, which is an entry point, which we don't touch in the Rstudio Docker because it already exists, but we touch, you'll see it in the Jupyter Docker, is actually a command that is run by default every time that somebody runs the Docker. So in our Jupyter Docker, it's actually a line that starts the Jupyter server, or it starts up Jupyter Notebook. If we're doing something fancier, like using Docker to run a pipeline, then usually the entry point is actually the script that runs the pipeline. So this is an example of the top of the Rstudio Docker that we're using for our course. So it starts from Rocker/Verse, which is a version of Rocker is a group who works with Rstudio to make Dockers. So it's great. So it's an Rstudio. It's a group. They're not me. They know what they're doing, and they create Dockers that work really nicely with Rstudio server inside of them. Verse means it already has tidyverse installed, so it's one version. And 4.1, this is the version of R that it works with. And then on top of Rocker, which is really useful in R, is that you can add this. They have installed in the Docker, actually this install2.r script, which just makes installation a little bit easier. And you literally, after that, just add the name of all the R packages you would like to be installed. The other bit, so this is another line. The other line, this one might look weird to somebody who hasn't done any kind of installation in the shell, but this is essentially the way that you can install wget, curl, and git, which are two functions that exist in the Linux shell. This is like a classic Linux shell install command that if you don't know it, you can copy and paste it from other people. And you can browse on Docker Hub to get more and more examples of how to do this. So once you've built your Docker, which is pretty exciting, you can test it locally by entering the folder that has your Docker file and typing docker build and then T. T is for tag, and then give it a name, and then type /, which essentially means build inside this folder. And you should see a lot of things happening. You should see a lot of things happening that look like the same thing. That a lot of the things that you see on the screen should look a lot like things you see on the screen if you've ever tried to install something in a Linux machine. But at the end, hopefully, you will have an image. If that all works, then you can kick yourself up a gear by actually putting that image on Docker Hub. So I said that GitHub was a great place to share code, but Docker Hub is a great place to share Dockers. And actually, I'm going to go to Docker Hub now to show you how simple this is. So I think you can make a Docker Hub ID for free pretty fast. Yay, okay. This is my Docker Hub page. It has my username, which matches my GitHub username. This is my free account. And you can see I have 2 Dockers that I host here, which are the 2 ones we use in the school. In the first one, actually, I'm going to show the KCNI School Jupyter one. It's a bit weirder. So you can see in Docker Hub, it shows you the Docker file. So this was the file that was actually built. And at the very end, you can see I run a command to start the Jupyter Notebook server. But mostly I grab from a layer that contains miniconda 3, and then I add a bunch of Python packages. Another thing that's useful is so I've got this configured. I think it's manage builds. Usually there's a button. I think it's in manage repository. If you can find it. Yeah, configure automated builds. There's a button here. And you can actually just attach it to your GitHub repo. If you have read access to that repo, and you can tell it tell it exactly what you want it to build. Wait, why does it have a slash? Oh, yeah, and you can point it to the Docker file. Okay. And it will build every time you push a new change to the repo. So every time you change anything in the repo, in this case, it builds a new Docker file with the tag latest. So that way, your repo and my repo is always building in the cloud. It's always there on Docker. And then people can pull for it. So everyone in the school can pull it. Okay, back to the slides. Oh. Oops, I've been answering that forever. Okay. So, awesome. Okay, so from building a Docker, I'll talk a little bit about running a Docker. So when we run a Docker, I'm talking. Go. You can go. Okay. So when we run a Docker, we type docker run, and then we type the name of the image. And the name of the image usually has, if we're pulling from Docker Hub, if the image is on Docker Hub, it usually has the format Docker Hub user, image name, and then colon, and then version. So in KCNI lessons, it's Dickie, Rstudio school, and then version latest. There's important options that we use in the school. We use this P option for port forwarding. because our Rstudio Docker actually creates an Rstudio server instance that talks to our browser, and to get the version, the Rstudio server that's living inside the Docker to be able to talk to our browser that lives outside the Docker, we need to use port forwarding, and we forward the 8787 port. Volumes are another thing that are really important when people are running Dockers. So volumes mount data to your Docker. So a Docker is like a virtual machine, or a container is like a virtual machine. It can only see what is inside the container or what has been mounted to it or connected to it. So the way we connect data or things that exist outside of the Docker to the Docker, you can think of it like another type of mini computer, is by using these .v or volume mount commands. This is really important to know because it means that if you add a file, so when we're running our Dockers, we're usually mounting the KCNI School Lessons repo into the Docker. But if you add data outside of the KCNI School Lessons folder, Docker won't be able to find it. So this is what the whole command looks like, and it's a little bit cumbersome. Luckily, there's this fancy thing called Docker Compose that somebody told me about before last year's course, which is amazing because it saves us the memory. So what the Docker Compose is a YAML file that's sitting at the base of your repo. So we can see in the KCNI School Lessons file, we can see a Docker Compose YAML file, which contains all of the options that we want to give to Docker by default when we run either the Rstudio or the Jupyter instance. So when we run Docker, so instead of typing a Docker command that's like multiple lines long and very difficult to remember, to start up the Rstudio Docker, all users should be able to type Docker Compose up Rstudio. And later on, when we're working in Python, you can say Docker Compose up Jupyter, and that will start the Jupyter repo. Okay, one more note about singularity. So we tend to get a question when we ask about Docker about can this be written in singularity? So singularity is a different type of container or a different type of container engine that was written especially for high performance clusters. And there's a reason for that. So Docker is very nice because it has a strong development community. It has Docker Hub. Everyone's using Docker Hub. It works on Windows, Linux, and Windows, Mac, and Linux. And it has this layers idea that shaves a lot of disk space. But it has one major problem, which means that it's a no-go on most high-performance clusters in that it needs root access. So root access is like the administrative access that you have when you install software on your computer. And this is something that no server, no shared space should ever let you have. So Singularity has a smaller developmental community, and Singularity Hub exists, but is less used, and people don't really know how to write it. And it only works on Linux, but it doesn't need root access. And the best thing about Singularity is you can convert Docker containers into Singularity containers. So the general answer to does this exist in Singularity is yes, because pretty much everything written in Docker can be converted to Singularity. So the workflow for most scientists is that they write all of their code, or they write all of their reproducible environment as a Docker specification so that it can work on any computer and in the cloud. And then for high performance computing, like using the CAMH SEC or Scinet from Compute Canada, they convert that Docker spec into a Singularity container. Converting into a Singularity container is pretty easy. You can actually build, I wrote this Singularity build twice, but you can actually build Singularity containers directly from Docker Hub. by just putting docker // and then the Docker Hub information. So this is how you can build the Jupyter instance. There's another way. There's actually a Docker container that converts. There's literally a Docker container that you can use to convert Docker containers into Singularity containers. So you can build your Singularity container on your home machine. That's another way to do it. And it's the way that I'm probably going to have to do it for the school, because there's this thing with root. We'll get into it. Anyway. And then the key to know is that your Docker command, so if somebody pushes a Docker and they tell you how to run it and they say you should use these options, then if you're calling it in Singularity, you need to use these options. So instead of saying -v for volume, you need to do -B for bind. Instead of -W for work dir, you need to use -W. And instead of P, or instead of port forwarding, you don't need to do it, because port forwarding actually already works with Singularity. And then one note, if you're building a Singularity container, you should probably not build from latest, or if you're pulling a Docker container that you really want to use for science, you should probably never pull latest, or specifically the thing called latest. Because latest is always the newest thing, or the newest version, but the newest version will not be the newest version 2 weeks from now. It will be a newer version. And if you want to actually remember which version you used, you should probably figure out what is the actual code for latest. So what is the actual version associated with it on Docker Hub, and pull that instead. I'll show this on Docker Hub. So if I go back. So let's look up Rocker, which is my new favorite thing. So Rocker is the group that creates binders that have Rstudio server inside. And they have a bunch of different flavors depending on how big you want your binder to be. The one that we're using in the course is called Rockerverse, which is actually, I think, the big one. Yeah. Because it lets you do some things. And if we look at versions of it, Rockerverse. If we look at Rockerverse, we can see there's multiple tags available. So there's a tag devel and there's a tag latest, but usually you want the top tag that has a number associated with it, because latest is going to get usually latest is the same as this one, but this one will not be latest. Soon there will be a like 4.2 or 4.1.43 or 4.2, and that one will be latest. So if you're writing code, if you're trying to remember what environment you started from, you should usually build it from a numbered tag. And that is everything I wanted to say about Docker for you guys. So with that, I wanted to remind you of all of the environments we have. I think we're going to end a little bit early, or we have lots of time for questions and lots of time for troubleshooting. And I also want to remind you, we can go into GatherTown early, and everyone who's having issues can join us in GatherTown. I will also be sending out an email to everyone who responded that they were having trouble installing Docker, to tell you to make sure that you're set up for Binder or for Singularity. And you can also chat with us in the Slack. And I want to tell everyone about our post-workshop survey. This survey is really useful, especially for Sejal and I, as we go forward, as we try to become grown-ups and teach in other places. Sometimes they want evidence that we've taught before and evidence that people liked our courses. So if you love this course, please go to the survey. If you hate this course, please also go to the survey and tell us what we did wrong so we can fix it. And the next time we give the course, people will love the survey. We'll love it, and we'll see us on the survey. So I'm going to put the survey as the call to action and the Binder link in the chat as we close. And I've been answering questions a little bit as we go, but are there any more questions or any issues people came up with? Actually, I'm going to close this. there any last questions or hold your peace? Well, thank you guys for asking questions throughout. With that, I think we're going to close her down for today, and I'll speak to some of you guys in the Gather chat. I'm really excited to talk to you. Yay. Cool. Thank you guys.